How's it going, folks? This is your Conics test review that I gave you in class today. So, as promised, I'm going to give you a really quick video. Shouldn't take very long, and it's kind of a rehash of what we did in class today. So help you get ready for your test, hopefully. And as I said before, a little disclaimer: these problems are not going to always yield very nice numbers, but on your test, I'll make sure that that the numbers are very nice for equations and plotting points and stuff. So just bear in mind, just it's done the same way. Just keep that in mind and follow the process that I'm showing you, and you'll be fine. All right, so let's do this first question. Identify the conic, which is, I can see that we have a positive x squared and a positive y squared, but the numbers are different in front of them, the coefficients. So this is an ellipse, okay? So we're going to go ahead and put the x squared, and we have a negative 6x, which will follow it. And then we will add a blank after that, because we're going to complete a square there. For the y squared, I'm going to factor out this 2. So I'm going to say plus 2, and then y squared, and then I say plus 2y, because 2 times 2 is 4y. That's what I wanted. 2 times 2 is 4. And then I add another blank. This constant term, which is 7, I'm going to kick it to the other side and make it negative 7. So this is going to equal negative 7. And because I have 2 blanks on the left, I'll need 2 blanks on the right. So this is pretty much the same process we're always following to get this in a graphable format. So we're going to say, okay, negative 6 is, half of that is negative 3. Half of negative 6 is negative 3. We'll square that, so that'll be 9. So that's what I'm going to add to this side, 9 to both sides. We'll take this middle term, half of that, half of 2 is 1, so we'll square that, so that's going to be 1. But on this side, I'm going to say it's 2 times 1, which is 2. So I got 9 minus 7, which is 2, and then plus 2, which will be 4. And this is a complete square, and this is a complete square. So we have x, half of negative 6, which is negative 3, all squared. And then we got plus 2. Y, half of 2, which is 1, all squared. And as I said before, 9 minus 7 is 2, and 2 plus 2 is 4. Because it's an ellipse, standard form ellipses should equal, the equation should equal 1. So we're going to have to divide both sides, everything really, by 4 to make this work out. So we're going to have x minus 3 all squared divided by 4. 2 over 4 is a half, so this is going to be plus y. Oops, I didn't mean to do that. Let's go ahead and move that back, and we have plus y plus 1 squared over 2 now. And then 4 divided by itself is 1. So this is your standard form equation of your ellipse. So we'll need a couple things. We'll need a center. Okay, and we need some vertices. That's what I'm asking you for. Identify the vertices. And we'll need the foci. Okay, the foci. Foci coordinates. Okay, so let's do the center first. Let's do this in red, I guess. So the center is just a coordinate, and we look at the x, and we're going to switch these numbers here and here for the center. So this will be 3 for the x, and this will be negative 1 for the y. So 3, negative 1 is the center of this ellipse. Okay, if I look underneath the x, I see 4. I know that the square root of 4 is 2. So from the center, I'll go 2 to the left, and I'll go 2 to the right. And I'm going left and right because right here is what? X, okay? Underneath the y, I see 2. The square root of 2 is root 2, okay? So the square root of 2 is root 2, and root 2 is about 1.4, okay? It's an irrational number, so like I said, some of these numbers are not clean for this test review. But if I go up about 1.4 and down about 1.4, as close as I can, that's kind of where the points are going to be for your ellipse. So we're going to go ahead and connect those outside points as best we can. And this will give me this ellipse, okay? It's not a circle, it's an ellipse. And the vertices are along the major axis, which is the longer of the two axes. You have an axis from here to here and an axis from here to here. And this is your, what are called your vertices, okay? Vertices. Up and down on the minor axis here and here, these are called co-vertices, just letting you know. Okay, but all I ask you for are the vertices. So I want this coordinate and this coordinate, which will be 1, -1, and 5, -1. So those are the vertices. No problem. The last thing you need to find are the foci coordinates, and since they're also on the major axis right here, it's called the major axis. And let's get a very noticeable color. I don't know. Maybe we'll try gold. Okay, that's not really easy to see. But the distance c from left and right from the center is given by c squared is equal to a squared minus b squared. This is specifically for the ellipse. And a squared is the bigger of the two numbers, which is 4, and b squared here is 2. So it's really equal to 4 minus 2, which is 2. So keep in mind, if c squared is equal to 2, that means c is equal to plus or minus root 2. And as I said before, the square root of 2 is about 1.4. So we're going to go about 1.4 to the left of the center and 1.4 to the right of the center. And these little dots right here that I'm trying to draw are your foci. Okay, right there and right there, right inside the vertices. So these coordinates, since we're moving from center left and right, we're only going to change the x value. Okay, the y value will be the same for these points as it is for the center, but the x value will change. We're going from center a distance of root 2 to the left, so it's going to be 3 minus root 2, comma -1, and the other one is going to be root 2 to the right from center, so 3 plus root 2, comma -1. These are the coordinates of your two foci, and that's the answer for number 1. So onward to number 2. Okay, I can identify this pretty easily because I have an x squared and a y squared, and the coefficients are not only different, but they have different signs. This is positive, this is negative. So this is a hyperbola. Okay, it's a dead giveaway. So because of these two square terms, the one that's positive is the y. I'm going to write that one first, and I'm going to start by factoring out 2. So I'm going to say, okay, 2 times y squared. Here's the other y term that I have. So what do I multiply 2 by to get -4? Well, by golly, that'll be -2y. 2 times -2y is -4y. Okay, I'm going to add a blank. We're going to complete a square here. Next, I'll have the -3, which I'll factor out of the x squared. -3 times what gives you 12x? That's going to be -4x, and then I'll add a blank immediately. So I've used up all these terms, except for this 8. This is going to move and become -8 on the other side. So this whole thing will equal -8. But since I've added 2 blanks on the left, I'll have to add 2 blanks on the right to keep it even. It's an equation after all. And we'll fill this by completing a square. So half of -2 is -1, square it, 1. So this will be 2 times 1 on this side, which will be 2. I have half of -4, which is -2, and then we square that, so it'll give me 4. And this will be -3 times 4, which is 12. Okay, so I have a completed square and a completed square. I'll have 2, and then a y, half of -2, which is -1, all squared, minus 3, and then the x, and half of -4 is -2, all squared. And then we got, let's see here, this is a -12. I didn't put that. It's -3 times 4, it's a -12. So we have -8 minus 12, which is -20, plus 2, so it'll be -18 is what we said in class. Well, it's a hyperbola, and like the ellipse, it should equal 1. So we're going to have to divide everything by -18 now. Very fun. This has the effect, though, of changing things around, because now I have a negative divided by a negative, which is the positive. Now x is going to be positive. So 3 over 18 is actually 1 over 6, so we're going to have x minus 2 all squared over 6. We got a positive divided by a negative, so we're going to have y minus 1 all squared over 9. And this will equal -18 divided by itself, which is 1. So this is your new standard form equation of the hyperbola. So there's a couple things we're going to have to identify here. It's going to be kind of no fun. The center, first of all, it's the easiest thing to find. We'll look at these and we'll switch these numbers just like before. So if x, it'll be 2, and y, it'll be 1. So 2, 1, right there. And now I have to find the asymptotes and the foci coordinates. So before I do that, let's actually graph this. This is going to help me if I graph it. So underneath the x, we're going to see there's a 6. So we're going to take the square root of that number. So we're going to take the square root of 6 is what I'm telling you. And the square root of 6, though, I happen to know that the square root of 4 is equal to 2. And the square root of 9 is equal to 3. Square root of 6 is somewhere in the middle between root 4 and root 9. So it's kind of in between 2 and 3 somewhere. Okay? And so I'm going to say that's somewhere between 2 and 3, maybe 2.4 or whatever, but somewhere in between there. So since that's underneath x right here, we're going to go about 2.5 to the right, just a guess. It's not exact, okay? And I don't have a calculator to work with to check that. So we're going to go 2.5 that way and about 2.5 this way. It's the best that you can do, really. And then we're going to take the square root of the number underneath the y here, and that's going to be 9. Square root of 9 is 3. That's going to tell me to go 3 up and 3 down. 1, 2, 3. And because this is a hyperbola, in customary fashion, we'll draw a rectangle connecting the outside dots. And then we'll connect the corners of this rectangle. And these will form my asymptotes, which the graph will not cross. Now, because the positive term is x and the negative term is y, that means it's going to open left and right because the positive term is the x. So we're going to have a graph that starts here at these vertices, and it's going to open this way toward the asymptote and this way here toward the asymptote. It's not a great drawing, but it's hard to do on a smart board. And it looks like this, okay? So it looks something like that. Yours will obviously be a little prettier than mine. And then we will have that. So we're going to find the, let's do the foci really quick. It's going to be easier. So we have what is called a transverse axis that runs through these vertices together, okay? And along the transverse axis, we'll find our foci. And that distance from the center to the foci is given by the Pythagorean theorem. We'll say that c squared is equal to a squared plus b squared. As it turns out, a squared is the first term on the bottom, which is 6, and b squared is 9 for the hyperbola. So what I'm looking at is that c squared is equal to 6 plus 9, which is 15. That means c will equal plus or minus root 15. Now, the same logic applies for this as we did up here. The square root of 16 is 4, so the square root of 15 is something just under 4, okay, just less than 4, 3 point something. But we're going to go along the transverse axis from the center, so we're going to go about almost 4 to the left and almost 4 to the right, 3 point something. So we're going to go 1, 2, 3, and then not quite to 4. It's going to be right here. And here I'll go 1, 2, 3, not quite 4, somewhere here. And these are my foci, here and here, okay? The coordinates are pretty easy to find since we're only moving left and right from the center. We're only going to change the x value of the center. So we'll start at 2 and then we'll go left by a distance of what? Root 15. So minus root 15. The y value is exactly the same. And then we'll have a 2 plus root 15. And then comma 1. These are my center and my foci coordinates. The only thing I lack for this question now are the equations of the asymptotes. The equations of the asymptotes, I'm going to need some, I need to clear out some of the stuff here so I can write. We're going to need some space. Okay, so let's get some space here. Let's get a color here. Let's see, here we go. So my asymptotes will be found using this equation. Y equals plus or minus b over a times x minus h plus k. If you're not sure what h and k are, it's these coordinates. This is h and this is k. It's the center. Okay, so we know h and k are 2 and 1. B over a is the only tricky part, and that's basically by finding a slope of one of these asymptotes. This line right here, it's rise over run. This is up 3 and over root 6. That's how we made this rectangle, remember? So the slope is 3 over root 6, but I don't like that because 3 over root 6 should not be written that way. You shouldn't have radicals on your fractions on the bottom. So we'll multiply the top and bottom by root 6 to get rid of it. So 3 times root 6 is 3 root 6, and root 6 times itself is 6. So this will actually reduce to root 6 over 2. So that's b over a. For me, it's going to be root 6 over 2, plus or minus this. I got x. Remember that h is 2 right here. And then k will be the 1 right here. Okay. So all I have to really do now is just distribute this. And then, simplify it. And then I have this answer, right? So see how easy that could be. So if I use the positive portion of this, I'm going to say this times x will be root 6 over 2x. And then if I multiply this by negative 2, the 2's cancel. And I have a negative times a positive, which is a negative. It'll be a negative root 6. And then I'll go around and add the 1. So this together will form my y-intercept, whatever that is. And it's irrational. Like I said, on your test tomorrow, you're going to have a nice clean number for this whole thing. But this is what I have for this question. That's my equation of one of my asymptotes. The other one is if I distribute the negative instead. And that's going to do some sign changes. I'm going to have a negative root 6 over 2. And it's going to change the sign of this guy right here. It's going to give me a positive root 6 plus 1. And that's going to be the other one. So these are my asymptote equations for this problem. And that's about all there is to that one. Okay? So just follow that process tomorrow, and you'll have nicer numbers, and it'll make sense to you, hopefully. So let's go on to the next question so we don't waste any time. These numbers in front of the square terms are the same, and they're both positive. It's a circle. All right, so I'm going to start with the x's. I'm going to factor out a 3. I have x squared. 3 times what will give me negative 12? That'll be negative 4x, okay? And then I'll add a blank to complete a square. Next, I'll have the 3y squared. I see no other y's in the entire equation, so I can just say, okay, plus 3y squared. It is a completed square already. There's no other y terms sitting out besides just the square. This will equal 2. And then I added a blank here, so I'll add a blank here so we can complete our square. Half of negative 4, as you recall, is negative 2. Square that, 4. 3 times 4, 12. So this would have been nice, except 2 plus 12 is 14, so I'm pretty sure that's not going to work out nicely, but we'll do the best we can. So we have a complete square here. It's going to be 3 times x, and half of negative 4 is negative 2 squared, plus 3y squared. This is equal to 14. I will now, if I see these numbers in front are the same, this is a dead giveaway. It's a circle, so you should really divide everything by that number, whatever it is. So you get this effect of canceling stuff. So I have x minus 2 squared plus y squared equals 14 over 3. So that, unfortunately, is what we have. And this is x minus h, by the way, squared plus y minus k squared is equal to r squared. So remember, h and k are your center. So the center of this graph, if you would switch these numbers, that one will be at 2. And because there is no number here, we say that number is 0. So your center is at 2, 0. It's right here. And the radius, r squared, is this kid right here, unfortunately. So the radius, r, if you take the square root of that, that's what it'll be. It'll be the square root of 14 over 3. It'll be positive because it doesn't make sense to have a negative radius. It really wouldn't have a circle. So what is that really? That's the hard part because these numbers aren't really nice. But I know that 12 over 3 is 4. And that 15 over 3 is 5. And 14, right here, is somewhere about right here. So it's in between 4 and 5, a little closer to 5. So it's going to be 4 point something. Okay? And if I take the square root of 4 point something, it'll be 2 point something. Okay? So I don't know what it is exactly. I can only guess. So we're going to say somewhere between 2 and 3 when I take the square root of that. It's going to be 2 point something up to the right, 2 point something up 2 point something left, 2 point something down, and then we'll try to connect these as best we can and make a makeshift graph for a circle. And that's as best I can do without a calculator using these irrational numbers. But as I said before, you're going to have a whole number for your radius tomorrow, so don't freak out on this part. That's what that is, and that's number 3. That's all there is. So let's go on to the last one. We've done the ellipse, the hyperbola, and the circle, so the only thing we haven't done is the parabola. That must be what this is, and we see that because we have a square term and a non-square term. So I want to get the non-square term together with any stray constants, which is the 16. So we're going to move the 16 over here with the y. So we're going to have y and then minus 16. Everything else, the x terms, will go to the other side. So they'll change signs. This was negative, but now it's positive. This was positive, but now it's negative. So that's where I am to start with. Okay, I'm going to go ahead now and look at this 2 and factor that out. So I'm going to factor out a 2. So I got 2 times x squared is 2x squared, and 2 times negative 6x. 2 times negative 6x is negative 12x. And then I'll add a blank in customary fashion. And here I still have y minus 16, and now I'll add a blank over here. Okay, so that's what I got. So what are the blanks filled with? Well, this is half of negative 6, which is negative 3. Square it, it's 9. On this side, though, it'll be 2 times 9, which is 18. So I have 18 minus 16, so this will be y plus 2. This will equal the complete square, 2 times x minus 3, all squared. Because remember, negative 3 is half of negative 6. I'll go ahead and subtract 2 from both sides to get rid of this. So the final equation is y equals 2 times x minus 3 squared minus 2. And that's the vertex form of your parabola. So we know the vertex right away. The vertex will be given by the opposite of this number, which is with x, which is now 3. And this one will stand alone as negative 2. This will be your y coordinate. So 3, negative 2 is the vertex right there. Okay. Now, which way does this parabola open? Well, we got y by itself. Okay, y by itself right here. So you only have 2 options when you get y by itself. It's either going to open up or down. Okay, that's the real question, up or down. Okay, well, the key is to look at this number in front of the parentheses. This is 2, and it's positive, so it's going to open up. Okay, so how do we draw this? How wide is this graph? Well, it's hard to tell. If possible, the best thing to do is to find x-intercepts, also called zeros. And all you do that is set y equal to 0. That's why they're called zeros. And then we'll just move this 2 back over. And now we have 2 is equal to 2 times x minus 3 squared. Okay, so it's the same thing you've done in Algebra 1. And we're just going to solve this for x. We're going to divide both sides by 2. Boom. These are gone. So 1 is equal to x minus 3 all squared. I will take the square root of both sides to get rid of this. So x minus 3 is equal to the square root of 1, which is really plus or minus 1. And then finally, I'll add 3 to both sides to cancel this. So x will equal 3 plus 1 and 3 minus 1. So 3 plus 1 is 4, and 3 minus 1 is 2. So 4 and 2 on the x-axis are my intercepts. So the graph will go through those points. It'll look like this, something like this when you're drawing, okay? Right on the inside of the parabola is called a focus. It's not going to be very far, but it's going to be right about there. This is called a focus. And then on the other side of it, near the same distance, we'll have a line going through a point here, and this is called a directrix. Now, that distance from the vertex to the focus, this very short distance right here, is found by the quantity called p, and p is always equal to 1 over 4a, and a happens to be this number in front that we keep using. So it's really 1 over 4 times 2, which is 1 over 8, so a very short distance from the vertex to the focus. And we're only going up from the vertex, so we're going to add to the y value, and this will not change this x value. So this focus What I'm going to do, since I know this value p is an eighth, I'm going to change this value of -2. I'm going to call it -16 over 8. That's the same thing as -2. And what I'm going to do is, since I'm going up an eighth, that distance here, I'm going to add 1/8 to it. So -16 plus 1 is -15 over 8. So that's the y coordinate of your focus. So your focus will be 3 and -15 over 8. That's the coordinate for this focus. We can write it here too if you like. -15 over 8. That's what the focus is. The directrix is going the other direction, an eighth. So instead of adding, we're going to subtract an eighth, okay? So this is going to give me a new number, which is -16 minus 1, which is -17 over 8. That's the y coordinate for this. But the y coordinate's the same for everywhere on this line. It's always the same. So that's the equation of the directrix. Since it's horizontal, we'll say y is equal to -17 over 8. That's the equation of the directrix. You can write it down here if you like. It's going to equal -17 over 8. Okay? Y equals. But y equals. It's really important you put that. Y equals -17 over 8. And that, your focus, directrix, vertex, that's everything for the parabola. And that's pretty much how it works. Okay? So you have everything there. Thank you for watching. I hope it's helpful. And, good luck tomorrow. All right. Bye-bye.